Hello everyone. So the first section of pressure loss calculations that we're going to discuss is the drill bit section, and drill bit is, as you know, is a part of basically the drill string system, and there are nozzles attached to that drill bit. So the purpose of basically drill bit is to rotate and cut the rocks at the bottom. At the same time, what it does is it helps us to remove the cuttings from the bottom hole. So the fluid comes here, and then the nozzles basically increase the velocity of your fluid passing through some of the nozzles, and as the velocity increases, it hits the cuttings at the bottom and remove them to the annulus. So drill bit, in addition to cutting the rocks, it helps us in cleaning actions as well. So by increasing the velocity of your drilling fluid. Now this increasing velocity of the drilling fluid causes some pressure drops, and that's what we want to calculate. So in the chapter 4 in book, it is discussed exactly how this equation is derived, so we are not going to go over derivation of this equation, but pressure drop basically is a function of the flow rate, is a function of cross-sectional area of the nozzles, is a function of the density of the drilling fluid, and it's basically calculated through the equation. So first, this equation that you see here is the velocity of each nozzle, velocity of the fluid through each nozzle, and there is a CD which is basically a factor, and this CD considers several parameters. For example, if you look at here, there is a small difference in the height of the fluid for, starting from the top of the nozzle to the bottom of the nozzle, and also there is basically this pressure drop across by friction that is basically happening inside the nozzle. So considering these factors, which usually are ignored in our modeling calculations, just specifically through the nozzle, we put a parameter to consider those pressure drops, and this parameter is called CD. So CD is a constant, and we use 0.95 suggested by researchers. So this is the velocity passing through the nozzle. Delta P here is PSI, and density is pound per gallon. So you convert this velocity into the cross-sectional area and flow rate, right? Velocity can be converted to cross-sectional area and flow rate. So substituting into this equation, we get to this final equation that describes the pressure drop across the bit. So in this equation, pressure drop is in PSI, again density is pound per gallon, and the flow rate here is gallon per minute. Sometimes we show it with GPM. A is total cross-sectional area of all nozzles. Usually drill bit have 3 nozzles, so you need to calculate the cross-sectional area of each nozzle, add them up, and this is that parameter. So this is total cross-sectional area of all nozzles. CD is the constant 0.95, and this number on the back is the conversion factor. So all the units, as I mentioned in this equation, are field units. So pound per gallon, gallon per minute, inches squared. That's the cross-sectional area that you need to use here in this equation. And that makes your pressure drop to be in the PSI. Okay, so let's do an example here. So we have a 12 pound per gallon drilling fluid flowing through a bit containing 3 32nd inches nozzles, right, at the rate of 400 gallon per minute. So what we are asked is to calculate the pressure drop across the drill bit nozzle. So we need to use the equations that we have here. So the first thing I want to calculate is the total cross-sectional area. So A total is equal to pi over, this is basically circular nozzles, right? And when we talk about 32 inch nozzles, that's basically the diameter of those nozzles, right? So what we need to do is to calculate the cross-sectional area of a circular nozzle, which is pi over 4, and with the conversion factor that we will apply later. So let's just write pi over 4, and then that's basically 3 of these 13 inches squared, right? We have 3 nozzles, that's what is mentioned. And then we have also this is basically 13 over 32, so I'm gonna factor out 32 out, right? So you could write it this way, or let me write it the other way so you guys don't get confused about that. So it's basically 13 over 32 squared plus 13 over 32 squared plus 13 over 32 squared. So this is basically gonna give you a number in inches squared. So after calculations you will get 0.3889 square inches, right? So that's your total cross-sectional area, and then we put it in the equation. So delta P beat is equal to 8.311 multiplied by 10 to the negative 5. That's equation 434 in the book, multiplied by based on this equation, multiplied by density multiplied by Q square, right? So your density is 12 pound per gallon multiplied by 400 squared, and divided by the CD value, which is 0.95. That's again squared, right? CD squared, multiplied by total cross-sectional area squared again, so 0.3889 squared, and that gives you 1169 psi, right? So that's how much pressure drops, and that's huge, right? So you need to consider drill bit pressure drop in your calculations. So that's it for video. We'll continue a bit on the bit calculations, and I'll see you in the next video.